right, currently at DEFCON, my first DEFCON, which has been pretty cool. I got to talk about Swift reversing yesterday at the Malware Village. So I decided I wanted to kind of go through it in a video while at DEFCON. And yeah, so let's just get started. So again, we're going to be talking about Swift. We're going to be going over a lot of Swift related topics here. So usually when you first open up a Swift file, you'll notice that the the symbols are mangled and it's not really pretty. So first thing I do is I just run the Swift demangler, and that's going to make things a lot nicer. Another thing that I do, I'm just going to move this over just to show the results better, so like the video doesn't get in the way, is because usually we use strings to determine like where we're going to start analyzing a file. We look for like interesting strings. It's hard to correlate the strings and where they're called from in Swift if you don't have like a way of parsing that. So I just have like a quick script that I run. So the Swift large string parser, and that's going to give me some strings of interest, and then we can find one to kind of play around with and see what it does. So if we look all the way to the bottom, we'll see failed to run update file with admin prompt and failed to run update download script. Those are two really interesting ones. We're going to start with this admin prompt one because that would indicate some kind of prompt to get user credentials. And this file is a dropper for AMOS, which makes sense that you would get the credentials and then leverage those credentials to get access to certain files and then steal those files, this is an info stealer related malware. So let's look at the address that's called. The script like basically just grabs the string and then prints out the address that it's called from. So I'm going to move this over, and we can see that we're inside of this function called, well, it's not very hidden, run hidden update script. We can kind of guess what that does. And this string is passed to the string.append method, and this will then result in this being printed out. So interesting, they left some error handling in here for us. Not sure why. So this is inside of an if block. So it looks like this is related to something that ran, and then it checks that potential return value. And if there was an error, then it will print this out. So that's good to know. So we know that this is going to try to run some update file with creds. So let's see how it does it. Looking at this return value that's inside of this if block, we see this return value is for the launch and return error. For anyone that's not seen like NS task related methods, this is going to be the return value for launching another process. So we know that there's going to be an NS task related here. So I'm just going to put task return just to make sure I have that set up. And we're going to just go up. All right, we're going to go in reverse and figure out this NS task setup. So we have the NS task class here being passed to this Objective-C alloc with zone. We're allocating and initializing this NS task object. So let's replace this variable NS task. So let's now go down and see what methods are passed to this NS task object. The first method we see is this set executable URL. URL in this case, in like Objective-C world or in Apple world, is a file path, right? So not like a network URL. And we're passing in this object that's going to be set up as the path that's going to be executed by this NS task object. So we need to see where this object comes from. This object, we're just going to rename this to help us, path executable. This is the return value of this bridge to Objective-C. So these bridging functions, you can basically convert Swift objects to NS objects, which are Objective-C objects. So you'll see that a lot when it comes to Swift and Objective-C. It's used a lot. This is the return value of this URL dot. So URL is the object, and we're using this dot notation to call this method. And it's actually being passed an argument here, which we don't see. But if we look at the disassembly, we can see it pretty easily. We have this bridge and link instruction, which is going to initialize this URL. It has the argument for the file URL with path. So we know that this is going to be related to the file URL that's going to be initialized as this Swift URL. This is going to return an X0, and X0 is going to be the argument to this bridge to Objective-C. So let's just go back over, move this over, and we know that this is going to be a Swift URL, so a path Swift URL. So let's go up, right? We're going to go in reverse, right? And we're going to go up and see where this is used. So we have some kind of print here, and we can see that this is going to be the return value of the string.init method, which is going to take bytes and some encoding. And this byte is going to be the string that's initialized. So this is going to be bytes for path. And if we go back up, we continue to go up, right? We work in reverse. We see that these bytes for path is actually the return value of the Swift init static object function. What's good about this function is we can ignore these two arguments here related to it, or this one argument that also receives its own argument. This is related to metadata, which we're not really worried about right now. But what's cool is since it's a static object, we can actually inspect what this object is. And that's usually in the form of this address or an address. Luckily, we have that. So we're just going to click on this. And we see that this is a path to user bin OSA script. Now, for anyone that looks at macOS malware, this might seem boring, but that's okay. We see OSA script used a lot by macOS malware. But we do know that this is going to be an object that we're passing in as as a Swift URL, which gets converted and then gets passed to NSTask. So, and the NSTask is going to launch this OSA script. So that's good to know. This is it should be hex 12 bytes long. So that's, I don't know how many bytes that is. That's 18 bytes. So we're just going to go back and change this return value. This is going to be OSA script path. Now we can go back down and we know that this OSA script path is going to be initialized as this path Swift URL, which is then set up as this URL.init, which is then bridged to Objective-C to convert that Swift URL to an Objective-C NS URL. So this is going to be OSA script path. Let's just put OSA script here. Okay, cool. So the next method that's passed to this NSTask is this setArguments method. This also receives an object, and this object is the return from this array.bridge to Objective-C. So there's a Swift array that is initialized and then passed to this bridge to Objective-C to set up an NS array that is going to be arg NS array. And we have another init static object method, which is being passed to this bridge. So we're initializing the Swift object and then immediately bridging it over to an NS array. So we have the address of this Swift array. So let's go in here. And the first thing we see, this is an array, right? And we have the element count, which is 2 elements. And the first element we have here is a small Swift string, right? So these are structs. 16 bytes long, so we have like the entire struct object here. This is a -e, which is usually used with OSA script. And then the size of this is actually all the way over here. We can see this E signifies a small Swift string and is the byte size of 2, so 2 bytes in length. So this is the first element of this array. The second element is actually a little confusing to see here. So Binary Ninja attempted to make sense of this object or this data, and it did see that there is an address within this data. And if we hover over here, we can see what looks like do shell script temp update there on the right. So it is almost correct, but it's a little confusing. So what we're going to do is we're going to undefine this. Since this is a large Swift string, it's similar to the small Swift string, We have this D to signify, that this is a large Swift string, and it's a size of 0x3b, which I'm not sure how long that is. That's 59 bytes, right? And then we have a pointer inside here, an address that's related to this Swift string. So it's in, due to Indianness, it's backwards. So I'm gonna try to type that in the best I can. You can do bb.read to actually read bytes from a certain address, and you pass in an address. So that's 10002438, and I need to add hex 20 offset. It's just the way that these large Swift strings work. 0x3b we know is the size, and that's going to print out the do shell script temp update with administrator privileges, which is going to prompt the user for their credentials, and it's going to run whatever this temp update file is. So now that we know what that is, we can copy paste this, go back. We know that it's related to this array, so we're going to just add a note here to help us remember. And this NS array is setting up the arguments for the NS task. So the OSA script is going to execute with the -e as the first argument, and the actual do shell script string as the second argument, and it's going to execute that file. What we don't know is where this file comes from. So let's just continue. This is going to launch that. This is just setting up a pipe, which we don't really necessarily need to worry about. So that completes this NS task, and then it's going to launch it. So let's see where this is called from, because we need to figure out where this temp.update file comes from. So we're going to go back up. Okay, we already talked about this here, and let's just click on this. And Binary Ninja in the cross references section here shows us that this is called here. So let's double click on that, drag this over, and we were here. So this is going to execute. I'm going to make a quick note. Execute OSA script with admin. Execute OSA script with admin. Okay, cool. So this is inside of a stack block. So it looks like this block is then going to be passed to another function to execute. And it looks like we're dealing with dispatch queues. So if we go down and we just kind of follow this block, we'll see that, yeah, so it's passed into the execute argument for this OS dispatch queue asynchronous. So it's just setting up, this is using the global dispatch system. We don't really need to spend time on that. We just know that it's going to execute this closure. And a closure in Swift is like a block, essentially. So cool. We know where it's executed from. We know that it's inside of a block that's passed into this dispatch queue. So we need to go back up. We're going to go in reverse. And we're going to see, oh, we see the string that we saw before. If we just move this over here, so my video is not in the way, we can see this failed to run update download script. Failed to run update download script was another interesting string that we saw when we were able to parse out the large Swift strings. So we would have ended up here anyways, if we didn't know like how this was called. So that's good. We're in the right place. This is going to print that out if something fails. So we're inside of this if block. This is a return value for something. Return value. And if we follow that, it's the same thing that we saw before. Launch and return error. It takes in this block. Kind of weird. And yeah, so it sets up another NS task. So let's just go through this one more time. We'll try to speed it up since we already looked at an NS task before. So NS task. Let's replace that. Cool, that's being initialized. We have the set executable URL is this object, and another type of URL.init, which gets an argument and then bridged to an NS URL. So this is going to be exec NS URL, and that is coming from here. So this is a Swift URL. And let's see where this comes from. If we go up, this same thing we saw before, the string.init call is accepting what looks like the address of something that is being classified as a block, which is pretty interesting. So let's just keep following this. These two are referenced similarly, so that's kind of weird. And we have this string also being initialized. So there's two initializations that are happening here. Let's go down to see where this is. Oh, this is going to be part of an array, which we'll cover in just a moment. Okay, so we're going to follow this, keep following it, and see where this comes from. We have this being initialized here. Okay, so we have two calls to this init static object, right? And we're accepting two arguments here. So we have metadata, and then we have the addresses of these static objects. So we can go and inspect these. So let's take a look at the first one. This is for the curl command, right? So curl, and we're reaching out to this domain here, and then we're writing that update file into the temp.update, and we are setting up, we're clearing the extended attributes. I don't even think that it receives attributes when you use curl. And then we're setting up the executable bit. So that doesn't launch it. It just downloads it, and it then clears extended attributes and then makes it executable, which then the second NS task that we talked about before will then run it with admin credentials. Okay, so let's go back. We know that this is going to be curl command. Yeah, let's put that there. And another init static object is here. So let's follow this. This is for bin bash. Okay, that makes sense. This is going to be our executable URL. So bin bash. And just to speed things up, we know that we're going to have these two arguments here, and the executable URL is going to be passed in here, and that's going to set that task up. This will be curl. If we go back up, this is going to be curl command. Yeah, use that. Is setting up an Swift array. So let's talk about that really quickly. This is going to be the size of the curl. The reason I know that is because since Swift strings are structs, we have the actual curl command itself, and then 8 bytes from there we have the size. So this is setting up an array, and the way that I know that is if we come up here, we'll see this alloc object, which is allocating space for a contiguous array. We can see that this is getting the metadata for a contiguous array of strings. So this is going to be our arg array. The first, if we get the offset of that plus hex 10, this is going to be related to like metadata for this. So we're not really worried about that. We just know that the curl command is going to be placed into this array. And this array is here, and it's bridged to Objective C, an Objective C NS array. So there's going to be the arg NS array, and that's going to be passed as the set arguments with the set arguments method to the NS task, and it's going to execute it. And this looks a little bit strange, but essentially this will be the bin bash that is going to execute. So what it's going to do is it's going to execute bin bash, reach out with curl, download this file. Once this NS task is done, it sets up the dispatch queue, runs this closure, and this closure is then going to prompt the user for their credentials and execute that file that was downloaded by the first NS task. So that file ends up being an AMOS sample that has a lot of detections on VT anyways, but interesting that they decided to use Swift as the dropper. So that's why we covered it. Hopefully that was cool. Time to go back to DEF CON. Got my badge ready. And yeah, so let's get out of here.